Hello guys, welcome to my YouTube channel. Here we discuss about different physical laws and different concepts of physics and electrical engineering and any other related to any topic related to physics. So today we will talking about just straightforward. We come to the topic that many students are still fumbling, that what do you mean by Ohm's law, what are the applications of Ohm's law today. So we will see the Ohm's law, and this is a very informal class, and you can put your questions in the comment box at any point of time. And if you are very first to my channel, please subscribe and support me to deliver more important topics what you need to understand and which are important for your exams as well as your courses. Okay, so I am Shujay Shah. I am associate professor in Department of Basic Sciences. So we will discuss many things in our YouTube channel. So let us start with. Okay, so today we will be like this all lectures, this whatever we discuss here, this will be related to like mostly of kind of a blackboard chalkboard kind of discussion. So here also we will have our first topic, our very first topic will be Ohm's law. So we'll talk about Ohm's law. What is Ohm's law, that we come to in a few moments. Okay, so what Ohm told, that the voltage drop, the potential drop across any conductor, the potential drop across any conductor is proportional. The voltage drop across potential drop across any conductor V. Let us write again. This is Ohm's law. So Ohm's law we are discussing here, and what we are telling you, that the potential difference across any conductor is proportional to the current passes through it. So that was Ohm's statement, and also this is also has some kind of condition. So condition 1. So condition 1 is the temperature is constant here. The temperature is constant. Second is no changes in physical condition, like there is no chemical reaction is happening, or no any kind of deformation is happening. So it is nothing happens. So it is basically like a stable conductor. So what was the outcome of this law? V varies as I. What is potential difference? What is current I? That will just get to after some time. After 1 minute we will get to know it. So now this is like an equation. This is a mathematical equation of a variation. So now this is to remove this variational sign, to remove this variational sign, we need a constant at the right hand side. So how to do? So then you can simply write down V equal to R, a variational constant, and I. So what actually Ohm did was he mentioned this particular material, this particular this parameter, not material, I would say it's parameter. He told it as it is resistance. He told it as resistance. So now let us what actually he did, and how we can tell what is Vi and R, how we will measure and how we will see. So what actually So what actually Ohm did was he took a conductor, and he simply connected this conductor with a battery. Okay, so now this battery will have a positive terminal and negative terminal, and the current will flow in this direction. For obvious reason, we know that the direction of the current. and this is the basically like the conductor. This particular thing is your conductor, right? So now let us see that this so now what he did, he simply put one ammeter in series with the conductor, and he also attached an voltmeter across this conductor. Excuse me. So what he was actually doing, so he plotted, okay, let us write it in a very better way. So what he was doing, what he actually did was, he actually what he was actually measuring, he was changing the battery voltage. Plotting at the x-axis and he was measuring the current in the y-axis, because the battery voltage can be changed by hand, and he was measuring it. So now what he actually observed that each time he took any kind of, let's say, he put his measurement, what he was getting, that he was actually getting experimental point in this fashion. So it may be different values, and then the actual curve, and if he draws the basic line, it passes through origin. So, and immediately when, let's say, the current was, say, the voltage was 1 unit, the V was 1 unit, and immediately he got that the current was also some, let's say, some x unit. Then he immediately changed it to 2, then the current become 2x unit, and when it is 3, when it become 3, it also become 3x kind of unit. So it was immediately he immediately find out this particular relation is valid when it says that if you keep on increasing V, the I will be keep on increasing in this fashion. Okay, so now let us go into the actual mathematical form here. So what we were doing that there was a circuit, and okay, now so what we can actually do, so let us say, so we have a conductor. Okay, now we place the battery here. Now the ammeter is placed in series with the circuit, and then you complete the circuit, because now we know that where the ampere to be placed, and then the voltmeter is placed in this fashion. Okay, voltmeter in parallel. Okay, that we all know, and this is the voltage source. So it has a voltage source V, and we know that the current passing is I. Okay, so now we know that the formula for our celebrated Ohm's law is V equal to IR, and this is actually, now we know this. Now eventually the curve what Ohm had, just to get a better idea, let us make it very effective way. So what actually Ohm did was he took this curve in this fashion and plotted I versus V in the x-axis, because that only he can change by himself, and I he can measure. So that's why V is an independent variable, and this is dependent, what actually we are measuring. Right now we are getting we are getting points like this fashion, and if we draw a straight line, it will passing through the origin. Now in this curve we can simply modify it, because it will be I equal to 1 over r times v, and this looks like a kind of y equal to mx, where m is your 1 over r, y is I, and x is v, correct? So this does look like a equation of straight line passing through origin, where m is the slope and where it is 1 over r here. So in this case, in this particular case, we can simply draw a triangle in this IV curve and name it as ABC. So the slope of this curve, the slope of the curve is basically BC by AB, and which is nothing but what is BC? BC is the change in the current, and AB is the change in the voltage. So we can write down BC as delta I, and this is delta V. So this delta I versus delta V, delta I over delta V is nothing but it is 1 over R. Okay. So just getting a conductor, if you have a conductor with you, let's say if you have a conductor with you, now you can apply a voltage and you can measure the current passing through it, and you can simply plot the different data points. Then actually you can draw this curve, and from the slope of this curve you can actually measure so now if you measure the slope, then your slope is now 1 over r. So therefore r will be equal to 1 over slope, or in other words it will be delta V by delta I. So if you can calculate delta V by delta I instead of delta I by delta V, you can directly calculate R. So this is also basically method to measure the I. So you can actually measure R by this kind of method. But yes, of course, you cannot measure very high voltage or very high resistance or very low resistance by this method. But yes, of the order of few ohms to few hundreds of ohm can be measured in this regard. So what will be the caution? What will be the caution of this experiment? So now we know that V equal to IR. That's our form for Ohm's law. So here the cautions will be never take the data for long time, because now we know that if the time increases, what will happen? The temperature of the conductor will also increase, and this will create the change in the resistance. This will create the change in R. So R will not be constant, which is actually there. So in the very beginning, if we remember it correctly, that the temperature should be constant in nature, right? So that should be there. Now here now we actually got this condition V equal to IR. So now this is it. So now we know, now we can grab a look at it. So V, now we know V has a unit of volt, and the symbol is V. I has a unit of ampere, and this is unit of A. This has a symbol of A. And the resistance has a unit of ohm. So which is nothing but written by Greek letter omega, capital omega. So we have VIR. So now we have got V equal to IR. So if we remember this thing, so many problem can be solved. There are many other forms also. I equal to V over R, then R equal to V over I, and so on so forth. These are the corollaries of V equal to IR form, but mostly if you can remember V equal to IR, then I guess no other things can be remembered at any point of time. Okay. Now once we know resistance, now here resistance is a physical constant. Resistance is a constant. Resistance is a constant for a material. Provided, so not only that, it is a material, but it depends on geometry or shape of the material. So but yes, of course, this has been discussed many years later by Ohm. So what actually R has a form. So R as a form of, so this R, this R. So yeah. So this R is actually dependent upon some constant rho times L over A, where rho is a constant. We get to know what is rho is some constant that we will discuss, and this is actually a constant. So this is so this rho is independent of geometry. So rho is some constant which does not depend upon the geometry of or shape of the material, and we can say this particular rho, you can find out that rho is equal to R A over L. Now A, this particular fella, this particular A is the area, and this L is length. So now let us have a better look on this. So let's say your R equal to rho L over A, and let us say you have a conductor, let's say a wire. This wire has a circular cross-sectional area having cross-sectional area A, and the length of the wire is actually L. So then we can say that, then we can simply write down that R equal to rho L by A, that's the definition. Also this we have seen that why this came actually. So R actually is dependent upon the length. It increases with length. When you keep on increasing the length, it increases, and R is inversely proportional to the cross sectional area. If you increase the cross sectional area, the resistance decreases. Now this is a This is a simple variation of two equation 1, and let's say this is 1 and this is 2. So if we combine these, we get a compound variation, and this gives us R varies as L over A. Now to get rid of the variational sign, we have to incorporate a constant. Then we get rho equal to R equal to rho L by A. Then this is actually a constant, and now we can show that this rho, whether the cross-sectional area is circular or rectangular, this rho doesn't depend upon that. So this rho is actually a constant, and sometimes it says that specific resistance is sometimes called the specific resistance, or it is also called the resistivity. Okay, so these are the name of this particular constant rho. But now what is rho? So we start with R equal to rho L over A. Now we know that R has a unit of ohm, L as a unit of meter, and A has a unit of meter squared, right? We are all talking about SI unit, okay? No other unit we are talking about. So then we can simply write down here rho equal to R A over L, okay? Now this R over RA over L, you can see that this gives you that ohm, or we can give it a symbol that this is ohm meter square by m. Only we are talking about units, so that gives you ohm meter. Okay, so this gives ohm meter, and that is the unit of resistivity. So this is called unit. This is the unit of resistivity, ohm meter. Okay, so this is the unit of resistivity that you can remember, and this is something will be useful for your future times. But in some time in commercial purposes, this ohm meter is sometimes is not used. So in like daily purpose, we also use ohm centimeter. So this is also being used for resistivity. That also there for your everyday purposes kind of thing. Okay, so this is all about resistance, and we can also measure resistivity by different method. But hopefully in this lecture we only talk about we can solve some simple problem also here. So here we know about, so in the summary we can say that we learned about Ohm's law, then resistance, then 3 resistivity, and then finally we came to the units of resistivity. Resistivity. Okay, so this all talk about only theoretical thing we have calculated so far. So let us have some kind of example. Let's say, in a circuit the voltage you have attached, let's say this. So you have so the current flowing through the circuit is given. So here V is given here 20 volt, and the current passing through this circuit is 2 ampere. Okay, so what is the resistance? What is the resistance? The answer is very straightforward. So we know that V equal to IR, therefore R equal to V over I, and which is given by 20 by 2 ohm equal to 10 ohm. This is simple problem, but you may not get that kind of simple problem. So what you can get in exam maybe. So let's say a conductor having the cross sectional area having 0. Maybe instead of area you can say that the wire radius, the cross section, the area of the cross section have a radius, so it has a radius of r equal to 1 millimeter, and the length L is say 10 meter. Okay, now the current passing through the coil, or the, say this is the particular resistance, let's say the wire, and it is attached to a voltage source of let's say 5 volt, and the current passing through it is, let's say, so the I here is given as 0.1 ampere. Let's say, for example, it may be weird numbers coming out not matching any physical material, so we can get it. So it is 5 volt. Now how to calculate the actual resistance, like if it is it possible, or we can calculate the resistance by, so our job is to find out the resistivity of the material. So now how to get that? Now we know that V equal to IR, so R equal to V over I, so which is equal to 5 volt by 0.1 ohm, so it is 50 ohm kind of thing. Okay, now we know that this R, again R is equal to rho L over A. Okay, so now we can say that this is rho will be equal to RA over L. Now we know that this R, it is 50. Now we have to calculate, this is 1 millimeter. 1 millimeter is nothing but 0.001 meter, correct? So it has a radius of 1 millimeter, that means 0.001. So we can calculate it. The area will be pi r square, r will be 0.001 millimeter square, and whole divided by the length of the circuit, it will be equal to 10. So now if you calculate something, some ohm meter will come into picture, and that might be your homework. So this is how you can calculate resistivity. So what we have, so let me just go through again. So we have given a wire radius, so which is converted into SI unit, then it is already, length is already there in the SI unit. Then you calculate the R first, R equal to V over I, and you get V equal to 5, which is given here, and then it is 0.1 ohm, sorry, 0.1 is the current in amperes. Now again R equal to rho L by A, then rho equal to RA by L. Now R is 50 and A is pi r square, because it's a circular, it's basically a circular cross section. So that gives you pi r square as your area of cross section, then length is your 10 meter, then you can just simply do the calculation and you will get the number done. So that's how you can calculate rho. So this kind of question might also you can face in your final exam, and that is important. So you can, so for the takeaways are, so the takeaways we can write down that it is one is V equal to IR, that is Ohm's law, then 2 R equal to rho L over A. Now in these two particular equation, there are like if it is R is given, so R rho L anything given, so there are 4 unknown quantities here. So there are like 4 unknown quantities. Out of these 4, if you get 3, you can calculate the fourth one. Here the unknown quantities are 3, so if you get 2, then you can calculate the other one. So this is it, and thank you for your time and watching. So hopefully it is like helpful for your future studies as well as your exam. So thank you. Thank you, ladies and gentlemen, for watching, and hopefully we will meet in our other videos where we can show you some other concepts, other tough things, more tougher things in the future, and hopefully that gives you some idea about Ohm's law. So thanks for watching. Please subscribe to my channel, and if possible, give it a like. Thank you so much. Bye bye.